Okay, cool. I got the microphone on this time. I think yesterday's video doesn't have any sound. Super fun. At least I figured it out today. Okay, so we're just going to finish up a smidge of yesterday. So we're going to find a complementary angle and a supplementary angle. We did it yesterday with degrees minutes. Today I want to do degrees minutes seconds. It's just these two, and then we're going to move on to what we're going to do today. But I just didn't want to leave you guys to figure it out on your own. Because there's at least one like this on the homework. So we're finding our complementary and supplementary angles, remembering that our complementary angle is when it sums up to be 90. Whoa, chunky marker. Holy cow. There we go. And our supplementary angle is where it sums up to be 180. So if we come down here, we're trying to figure out our 54 degrees, 31 minutes, and 10 seconds plus what equals 90. But we didn't write it as 90 yesterday. We wrote it as minutes and seconds, where we had 89 degrees. And we could put it as 60 minutes, but I also need seconds. So instead of putting it as 60 minutes, let's take one away and do 59 minutes and 60 seconds. That still totals up to 90 degrees. It's just the longest, hardest, most complicated way to do so. Because if nothing else, we are going to overcomplicate things. Everyone see how that totals up to 90 degrees? All right, so then let's figure out what is our complementary angle here. How many, and I tend to work it right to left. How many seconds do we need on our complementary? We need 50 seconds. How many minutes do we need? 31 minutes to 59 minutes. 31 plus what is 59? 28. And how many degrees do we need?
35.
So what we're doing is we're subtracting 89 minus 54, or 54 plus what is 89? 10 plus what is 60? 31 plus what is 59? You can think about it in a couple of different ways, either doing it as subtraction or doing it as kind of a reverse addition. You wind up at the same place. So we're going to do the same thing with our 54 degrees, 31 minutes, and 10 seconds. But this time we're going to do it for our supplementary, for our 180 plus beta. But instead of writing it as 180 degrees, we're going to do it the obnoxiously complicated way, where it's 179 degrees, 59 minutes, and 60 seconds. So what is our supplementary angle going to be? 125 degrees. 28 minutes and 50 seconds.
Basically just add 90 to whatever you got.
Pretty much, yeah. Yeah. Yeah, if you know the complementary, you can add 90 to it and get your supplementary. Because the angle we started with didn't change. One more like this, but it's not harder. It's just another practice like this. Okay? Once we get the hang of these aren't awful. They're weird. I would give you that. But they're not mathematically difficult. The calculations on them are not awful. So our last one that we're going to do like this is our 81 degrees, 49 minutes, and 56 seconds. And we're going to start with our complementary angle. So we're going to do our 89 degrees, 59 minutes, and 60 seconds. So what is our complementary angle for this one?
98 degrees, 10 minutes, and 5 seconds.
So I'm with you on our 4 seconds and our 10 minutes.
8.
How many degrees?
8.
8 degrees. I think you were on the supplementary. It just took me a minute because I didn't actually put this one on my notebook. So I'm like, where did we get that from? There we go. I got you. Yes, dear. Yes, the 10 is minutes, not seconds. That's what happens when I think and write at the same time. If I try and think and write at the same time, I write things wrong. All right, our supplementary, it's 90 degrees more than that. You can calculate it by itself, or you can realize, hey, if I just take my complementary and add 90, we are right exactly there, just like Henry pointed out for us. So we're at 98 degrees, 10 minutes, and 4 seconds. Again, the minutes and seconds, I mentioned this yesterday, it's not used super commonly. Mostly it's used in things like GPS coordinates. And Precal. So we're going to be talking about angles a lot. So we need to be able to have common wording on what we intend when we're talking about angles. So we're going to talk about angles of rotation. And we're going to be naming and sketching angles a lot today. So what we're going to start with is angles of rotation in what we're calling a standard position. We're not going to wind up with angles kind of all over the place. We're going to base them out of a home base. And what the standard position of an angle is for what we're talking about, our standard position has the initial side or the starting place on the positive x-axis. So when we're looking at pictures, we're going to talk about, let's see, we can get a slightly thicker marker so we can see it. This being our initial side. We're just going to base them out of there. We are going to call positive angles the way we measure them in a counterclockwise direction. Or an anti-clockwise, depending on if you watch way too much British television. Watch way too much British TV. So what that means is we're going to look at them going this way. So if I said it was a 60-degree angle, I would go up this direction. This would be counterclockwise, going up through quadrant 1, then quadrant 2, then quadrant 3, then quadrant 4. Negative angles, if positive angles go counterclockwise, negative angles go clockwise. That is based on, analog clocks. From initial side to terminal side. So if we had like negative 60 degrees, it would go down this direction. This would be a negative angle. This line we started with, we call that our initial side. And this line that we ended with, we call the terminal side. So it's where we started, initial, terminal, where we end. I keep doing I'm gonna give you a second. So what we're gonna start with is we're gonna start with sketching, and we're gonna use degrees to begin with to work with what we know, and we're gonna sketch some angles. So we're gonna just sketch them based off of the kind of rules we just gave ourselves. So we're going to use a coordinate grid. So for each of these angles, I'm going to draw a grid. This is our initial side. I'm going to call it 0. We're always starting on this x-axis. What number of degrees would get me up to this line right here? 90 degrees. What number of degrees gets me over to this line over here? 180. So we can label some things if it helps us. On this first one, it might not help us all that much. And if I go all the way over to this one, it's 270 degrees. We, for the most part, use positive angles. We're going to come up this direction a lot. But we're just going to kind of eyeball. We're not using protractors here. We're not busting out the compasses. We're sketching. That's why it says sketch, not graph. Graph means to be specific. Sketch means close enough. So 60 is somewhere between 0 and 90. So we know we're definitely over here somewhere. And it's a little closer to 90 than halfway, because halfway would be 45. So I'm going to put my angle right about there. I think that's about 60-ish. I'm going to call it 60. We're sketching. We're getting it close. We're practicing going up clockwise from our x-axis. If you want to do these all on the same graph, like the same little sketch, you can. I'm going to do separate graphs for each of them just so we can see clearly what I'm drawing. But it's going to start out the same way. I'm going to label my x-axis as my 0. I'll do this one in kind of purple. I know this one's going to be 90. This one's going to be 180. And this one's going to be 270. So when we're looking to draw 250 degrees, we're starting at our initial side and we are going counterclockwise past 90, past 180, but not quite all the way to 270. So somewhere over here is our 250 degrees. So positive angles, we always start with going up. I may go up and around a couple of times. Sometimes they'll give you something like 700, and you'll just go loop-de-doop-de-doop-de-doop until we hit it. The only time we do not start out with moving up first is when we have these negatives. So again, I'm still going to label it with my positive values. 90, 180, 270. But now I'm going to go down 100 degrees. because this is negative 100. So I'm still starting with my initial side on my positive x-axis. But I need to go down for 100 degrees, which is going to go just past the 90. So somewhere around here is negative 100. That makes sense. I feel like I didn't do a ton of explaining, just showing. Questions on this part, because it's about to get real weird. Just saying, we are going to move into, this is going to be kind of the language we use for a lot of the next few chapters. We're going to be working with something called radians. And it is an entirely different way of graphing, writing, and making angles. Radians is going to be a lot of what we work with. And radians are weird and tricky to get used to. I promise we'll get through it. What it is it's relating the length of the side of the circle to the radius of the circle, and using that to talk about our angle measure here. So it's really weird, because what it is 1 radian is if we were to take the radius. I'm gonna get rid of those. So if I take this circle here and I grab measuring tape, my oh so fancy, super high tech, totally didn't steal it from IKEA, paper measuring tape, and I measure my radius. Fine, let's do that. It's gonna be crappy, but we'll do it. And I measure my radius. Don't change things. So this radius here is about 10 inches. If I go up along my arc 10 inches, put it right about there. Will it let me mark it? No idea. I've never used it. Right about 10 inches. Right about there. So my arc length was the same as my radius. So the measurement of this angle we call 1, that is the fattest pen ever, oh my gosh. There, that one. We call that 1 radian. So then we could go another one, and I could go another 10 inches around. Go this way. And then this angle would be 2 radians. I could do another one and go another radius length across. Put me out here. And then the angle of this, or the measure of this angle, we call 3 radians. Take control back. There we go. How far do we think we're going to go until we wind up all the way flat here? That's going to be. Because we had 1 here, 2 here, 3 here. How many until we hit that pink line? Three and a bit, right? 3.14, 1, 5, 9, 2, 6. It's pi. So to get all the way to our supplementary radian, like all the way over, it's measured in pi. So if we start at 0 radians, to get to a flat angle all the way across, it's actually pi. And we are going to be working with radians a bunch, and we are going to practice naming, labeling, and drawing radians probably for the rest of today. And we're going to be relating radians to degrees and all that stuff. It's a different way of measuring angles. And we're going to be sketching some radians. And since we're going to sketch them, I made pictures. So you guys can have circles on your thing that are actually, proper circles. I'm grabbing the boxes with the glue and stuff. I haven't had them out yet this year. So that you guys can have proper radian graphs. I mean, these are, I would scare you with the full radian graph because they look really weird. But it's a circle on an axis. And I have lots of these, and I'll print you guys more of these as we need them. Like I can make a gazillion of them. Alright. So here's circles. And because what we're going to do next is we're going to practice kind of drawing some radians. But that means we're going to want to label these axes in a way that we can do kind of like we did with the 90 and the 180 and all that stuff. Oh, I gave that for my table. Sweet. Okay. So before we start trying to sketch graphs, I want us to figure out what our labels are going to be for all these axes. Like we had the 0, the 90, the 180, the 270. The same kind of way. No, I made it for you. That's what these are. Yes, sir. Oh, yeah. I got a whole nother box up here. If the glue sticks are ever dead in your box, let me know. I have gazillions. It's just a matter of getting them out. Oh, I love it. I didn't give myself that picture. No. Like that. No, naturally no. All right. We're gonna. Copy page. There we go. Paste. There we go. All right. I promise I still have them on a previous page. I just copied it so we can actually figure out what our labels were. Because we're starting with 0 over here. And we just saw that we have pi over here. So what can we do to label this side? Half of pi. Exactly right. Pi over 2. Or 1/2 pi. We're going to tend to write it as pi over 2, just for future reference. We will write it a gazillion times. Y'all are going to get really good at writing the Greek letter pi. So what can I do to label the bottom one? Down here. Not quite pi over 3. Not quite. I see where we're thinking, but you flipped it in your head. Because this, pi over 2 is on the top.
Pi over 4?
1 pi and a half.
1.5 pies. Common denominator that.
3 pi.
3 pi over 2. It's 1.5 pies. Because we go all the way to pi, and then we do another half a pi. Okay, so we can also have this side labeled as 2 pi. These angles wind up going in circles. So this could be 2 and a half pi. This could be 3 pi's. This could be 3 and a half pi. So they just keep going in circles over and over and over and over again. Okay, because all we care about is the angle in the middle. So what we're going to do here is we are going to sketch some angles. And what is happening to my screen? There we go. So these are the angles we're going to sketch. I didn't give myself a circle because I am a jerk to myself. So I'm going to do these on the previous page, and I'm going to color code them. So give me a second. Let me white out this text. So I'm going to use this circle, and I'm just going to do them in different colors. Also, if you are ever working in your notes and you would like to color code stuff, I have a gazillion colored pencils, markers, etc. So if you want those, just let me know. So the first one we're going to do is we're going to find pi over 4.
In the middle
More specific.
of the pi two.
Yeah, right in between these two. Because if this is pi over 2, pi over 4 is going to be about halfway. So we start, again, we always start at that initial side is right here. For all of these angles, this is going to be our initial side. So pi over 4 is going to be right here. All right, how about negative pi over 3? Yeah, it's going to be about a third of the way down. Because we're negative, but we're going to go down. So this one is negative pi over 3. I'll come back here and label this blue one properly. This one was pi over 4. All right, next one's a little bit harder. 4 pi over 5. Close. It is definitely going to be on this left-hand side. We know it's more than 90. Is it going to be past pi or not quite to pi? Not quite to pi, because it's 4/5. So it's going to be just a smidge less than pi. So that was, I have that in that kind of lilac color. So you can think about it as like dividing this whole thing in 5, but 5 is one of those like super awkward fractions to eyeball. So we're just going to put it here. So this is going to be 4 pi over 5. And this last one is, let me get a color that we can actually see. There we go, we'll do that. 3 pi. Where's 3 pi gonna be? pi. Yeah. All it is, it starts at the initial side. 1 pi, 2 pi, 3 pi. So this angle, it's a straight angle. So this is pi, this is also 3 pi. And I agree, these are weird, confusing, and make very little sense. And I promise it will eventually start to get better. But radians are weird. And to be fair, this is, as far as I am aware, the best way to introduce it, even though I know it makes our brains hurt. Because we go, what the heck? If you are going, what the heck, you are not alone. Okay? They're weird. First time I learned radians, I think it took me about a month to figure them out. I go, oh, okay. You will have your oh moment, I promise. Probably not today. But what we're going to do is we're going to take radians and degrees and we're going to relate them together because we are significantly more comfortable with degrees, right? We've worked with degrees for eons. So what we have here, I know that 0 is 0 in degrees. We started here with degrees as well. I know that over here is pi because I told you that. So if I know that 0 is still the same, and I know that pi is the same thing as 180, we can convert. Oh, those are the sketches that we just did. What we're going to do is we're going to convert from degrees to radians and from radians to degrees. 180 degrees is the same thing as pi radians. So we're going to do it as a unit conversion. So what we're going to do is we're going to start with 50 degrees. 50 degrees. And we're going to do this as a unit conversion. I know that pi radians equals 180. So we can do this as a rate. Pi over 180 degrees. That makes the degree cancel out and we'll be left with radians. Oh, those purple and blue are way too close. So we're going to have, and I'm just going to not simplify right on this step. We're going to have 50 pi over 180. Technically correct, but not good grammar. Can we simplify that? How? Divide both of them by 10. So we're going to have 5 pi over 18. Can I simplify it any further? Nope. That is our radian measurement for 50 degrees. Radians look super nonsensical. It relates our circumference to our radius in weird ways. If we think back to that definition of what a radian is, this is the length along the circumference for an 18 radius circle. So like, I know the radius is 18 and it goes up 5 pi's. Doesn't super help us right now, but that's what it's doing. It's relating the arc length to the radius to figure out the angle that that makes.
But isn't it the same thing as 50 degrees?
Yes.
So why would we need to convert?
Why do we need to convert from feet to centimeters? It's because there are functions we're going to work with later on where things have to be in radians because mathematicians make things overcomplicated. Kind of the theme of the year. Mathematicians be crazy. So yeah, we have a lot of functions where we have to use radians because of the way that circumferences relate, and we'll wind up with a lot more decimals in degrees than we will in radians, because in radians we will leave it as pi. We're almost never gonna actually use the numerical value of pi. We're gonna leave it as pi most times. So let's do the next one, negative 75. And we can just leave it negative. Like, that's totally fine. We do not need to figure out the positive value of it. We're going to treat it exactly the same. Negative 75 degrees. And to convert it to radians, we're going to do, there's pi over 180 degrees. Pi radians per 180 degrees. That makes the degrees cancel out, and we're going to be left with radians. So I have negative 75 pi over 180. Can we simplify it? What do we get when it simplifies? Negative 5 pi over 12. That is our radian measurement. Same thing with the 215. (215 degrees), and we're going to do pi over 180 degrees. Makes my degrees cancel out. 215 pi over 180. And we can simplify that. Exactly right. 43 pi over 36. I know that doesn't seem like it helped at all, but it did. I promise, once we start working with them and not just using them as a unit conversion, they do make sense. Naturally, if we're going from degrees to radians, I wonder what's next. They're not super long calculators, so we can squeeze them in. We'll fit them in. They don't take super long because we do the exact same process to go the other direction, from radians to degrees. And this will be where we end. This will be the last page for today. Because we're going to take our 5 pi over 6, and this time we want to convert it to degrees, so I'm going to put my degrees on top. 180 degrees for every pi radians. What happens with my pi's? They cancel. So we wind up with 5 times 180 over 6 degrees. Can we simplify that? Yeah. How can I simplify this right here? The 6 and the 180. What does the 180 become when it divides by 6? 30. Because 18 divided by 6 is 3. So we have 5 times 30, 150 degrees. So 5 pi over 6 is 150 degrees. So this little section right here is just unit conversions. So we're going to have our 3 pi over 4 and our 180 degrees over pi. Our pi's cancel. And we can simplify the 4 and the 180. What do you know what 180 divided by 4 is? 45. We do 180 divided by 2 is 90. 90 divided by 2 is 45. So 3 times 45, 135. Okay, so there's one left up here, but we have less than a minute to the bell, so I'm not going to take you there. So I encourage you to try negative 3 pi over 10. Process is 100% exactly the same. And tomorrow we will play more with section 6-1. Boop. But we're almost to the end of section 6-1. We're almost there. I think there's like 2 questions on the homework that we haven't touched yet, but just 2. All right. Drop my ruler.